Inside this massive dataset, the argument over whether AI belongs in the software development lifecycle is entirely over. The adoption curves have bent permanently upward. What remains open, and what Linear itself admits is now the only question that matters, is whether any of the new output being generated is actually valuable. Pull requests opened per team are up 111% since June 2024. Splitting the cohort, teams without an agent moved from 8 to 10 weekly, while teams with an AI coding agent saw massive divergence, tripling output from 21 to 65. The sheer volume of new code arriving in the repository proves the mechanics of production have accelerated. The primary constraint on a software team is no longer the speed at which it can type code. The burden has shifted entirely to the speed at which it can validate it. Before analyzing who is generating this code, we have to define the instrument. In this report, an AI active user is anyone who registers a single AI interaction or agent session within a 28-day window. This is a loose filter. One touch a month qualifies, meaning these curves measure initial contact and exposure, not necessarily a daily habitual reliance. Furthermore, Linear only counts pull requests in repositories directly connected to its own system. Any code shipped outside that loop is invisible, making these already high-volume numbers an absolute minimum floor. With those boundaries set, the demographic data dismantles a standing industry narrative. The widespread assumption has been that AI tools are a grassroots phenomenon, championed upward by rank-and-file engineers. This role adoption chart shows the exact opposite. Product management adoption surges past engineering, hitting 34%, while engineering trails at 30%. The hardest pivot happened at the top. In companies over 200 employees, CEOs quadrupled personal usage, spiking from 9 to 36%. This suggests that senior leaders are learning the technology through direct personal use. As executives engage with AI features at these rates, the traditional boundary between high-level strategy and hands-on building is beginning to blur. If you read a vendor deck for a coding agent, the value proposition is identical. The AI will automate rote tasks, freeing up massive amounts of time for deeper strategic thinking. Linear's time-tracking telemetry completely rejects that promise. According to the logs, time spent on project planning, documentation, and customer requests remained completely flat between June 2025 and June 2026. The time the AI supposedly saved was not banked. Instead, minutes spent on issue triage, commenting, and chatting with the AI itself grew across every single organizational function. In economics, this pattern is known as the Jevons-paradox. In the software pipeline, the increased efficiency of code generation induces demand for even more work, driving the total volume of the system upward. Chatting with AI and delegating issues to agents did not replace previous duties. It emerged as an entirely new layer of operational overhead, stacked directly on top of the existing workflow. The data is remarkably clear. AI does not create free time for the organization. It aggressively reinvests every saved minute into higher system load, into much more coordination, and longer work hours. The immediate operational consequence of this induced demand is a massive influx of code, and critically, that code is arriving from entirely new sources. This pipeline funnel illustrates who is actually opening the pull requests. Over 2 years, the share of product managers actively attaching PRs jumped from 3% to 10%. Simultaneously, the share of design team members shipping code grew from 1% to 8%. The people who historically wrote the specifications for a feature are now using agents to ship the actual code changes themselves. This introduces severe structural risk. New contributors generate complex functions, but lack the technical depth to fully review the code their AI authored. Unable to review their own work, this generated code flows downward, slamming directly into the senior engineering review queue. If managing a software team today, you must actively budget for increased code review capacity. The vendor decks will tell you to reduce headcount, but the telemetry demands you hire more reviewers to handle the incoming wave. If you want immediate analysis of operational data like this the day it drops, subscribe to the channel. We track the telemetry so you don't have to. Treating AI as a pure efficiency tool is a trap. It is a raw load multiplier. If the review pipeline isn't scaled to match the generation rate, The traditional software team structure will simply break under the volume. We need to return to that staggering headline metric, the gap between the agent teams shipping 65 pull requests a week and the traditional teams shipping 10. This exact spread will be heavily quoted across the industry to sell software. But a close reading of the report's methodology reveals it cannot support that spread as a causal claim. Look closely at this timeline, specifically zoomed in on the starting point in June 2024, a full 2 years before the peak. Before a single agent was ever connected, the experimental cohort was already shipping 21 pull requests a week, compared to the control group's 8. What we are looking at is severe selection bias. These teams were not randomly assigned in a controlled trial. They chose to use the agents themselves. The teams that possessed the operational bandwidth and technical aggression to test unproven coding agents were inherently the highest throughput teams to begin with. Attributing the massive endpoint growth entirely to the AI tool completely ignores the fact that a substantial performance gap existed long before the tool was ever installed. The overall shift in market activity is undeniably real and heavily documented, but no definitive productivity multiplier can be honestly quoted from a cohort with this degree of self-selection. Linear, to its credit, hands over the final piece of the puzzle itself. They openly admit that they have no way of knowing whether this increased output actually led to positive business outcomes. There is a strict difference between system motion and business value. A tripling in pull request count is just as compatible with a tripling in refactor churn and broken builds as it is with shipped features. To see this tension clearly, look at this split screen comparing Linear's volumetric telemetry against the outcomes of the rigorous MET trial from 2025. In that controlled environment, experienced open-source maintainers were actually 19% slower when using AI assistants to solve real issues. And as we covered previously, industry data already shows production incidents rising by 242.7%, which is driven by AI agents writing code that passes initial local tests but fails catastrophically in deployment. Throughput logs and controlled outcome measurements are currently pointing in completely opposite directions. There is a single missing metric that Linear could compute to bridge this gap: the revert and rollback rate of those connected repositories over the exact same 2-year window. If the revert rate for the 65 PR teams stayed flat while volume tripled, then the AI output represents genuine surviving value. But if reverts climbed alongside the volume, that headline growth figure is measuring nothing but unverified rework. Until the industry can accurately measure the survival rate of AI-generated code in live production, we are blindly scaling throughput while entirely ignoring the rising cost of failure.